Hi, it's Mr. Benson here with a short video on non-linear graphs, which is the last part of the standard Year 9 level work. Now, it's not a very difficult concept, and it's using skills that you've used before, so shouldn't be too hard. Okay, so firstly, let's think about linear graphs. Now we know that linear graphs make straight lines, and we know that they have this standard form that we've seen quite a lot of, this y equals mx plus c form. Now the important thing about linear graphs is the value of the index for the x, or the power of x. Now remember from our work in indices that if we've just got an x by itself, then it's the same as x to the power of 1. So that's the whole thing with linear graphs, is they've got x to the power of 1. Now we can have a look at some other forms of graphs now, and other forms of equations. So we can have other equations that are non-linear. So we know that a linear equation has x to the power of 1. So what about an equation which has x to the power of 2, or one that has x to the power of 3, or what about one that has 1 over x? Now if you remember from indices, 1 over x is the same as x to the power of -1. So those would all be non-linear equations, and so they're going to have non-linear graphs. And so I've got some examples here of graphs that are clearly not linear. Now I'm not telling you what particular equations these correspond to at the moment, because that's what we want you to find out. Now all we need to do at the moment is just have a go at plotting some non-linear graphs. And so we start off by filling a table of values, and then we're going to plot those values. Now I've just made up a relatively simple what's called a quadratic equation for my example here. And all we do is we calculate the value of y that corresponds to the particular value of x. So for my first one here at -4, I'm going to so when x equals -4, y will equal -4 squared plus 3 times -4 plus 2. And okay, so -4 squared is 16 minus 12 plus 2. 16 minus 12 is 4, plus 2 is 6. So that's the value there. And then I've just got to keep working through. So -3 squared is 9, plus 3 times -3, well that's -9, so that's 0, plus 2. -2 squared is 4. Now minus 6 gets us -2, plus 2 gets us 0. Now -1, well -1 squared is 1, minus 3 times or plus 3 times -1, so that's going to get us down to -2. Plus 2 is going to get us to 0 again, which is kind of interesting. 0, well 0 squared plus 3 times 0 is all 0, but we're back to 2. 1 squared plus 3 times 1 is 4, plus 2 gets us to 6. You might be noticing a pattern here. 2 squared is 4, plus 6 is 10, plus 2 is 12. 3 squared is 9, plus 9 is 18, plus 2 is 20. And 4 squared is 16, plus 12 is 28, plus 2 is 30. Okay, so we've got our table of values. Now what we would probably want to do when you're plotting this on paper is to do a wider domain here. So my domain, which is my x values, is only from -4 to +4. It would probably be good to graph a slightly bigger one, maybe even up to -10 to +10 in some cases. But you'll probably get a good sense for what's going on just by doing a shorter domain. So remember, the x values are the domain and the y values are what we call the range. Okay, so let's sketch this one. Now you've got to think about the scale that you're using. Now our x is easy because it's just the values that we've used and nothing particularly complicated is going on there. So I'm just going to fill those in. So -4 up to +4 on my x-axis. On my y-axis, this is a little bit messier because we've got some really big numbers going on. So we've actually got to go up to 30. Now, look, I'm going to, just to keep my life simple, I'm going to make these 10s on the axes. So then we start plotting. Now at -4, we're about 6, so that's going to be about there. Now if you're doing this on graph paper, it'll be a lot easier. -3, we're at 2, which is going to be about there. -2, we're at 0. -1, we're also at 0. Then we go back up to 0.2, 0.6, and then it gets kind of interesting because we're starting to jump up into the somewhat bigger numbers. 12, actually my 6 is a bit high there, but that's all right. 20, and then 30. Okay, and so you can start to see that we're getting a kind of an interesting curve developing here, which I'm going to try and sketch. Oh, that was terrible. In fact, this is the worst sketch probably you've ever seen in your lives. But you can see that we're getting a nice curve developing in our graph here. So it's clearly a nonlinear graph, and your task will be to look at graphs like this and see if you can start to relate the equations to the graphs.